amazing pre-algebra students. This is Mrs. A, and I love math. Today we're going to cover Lesson 8 in our Saxon Course 3 book. And it's all about perimeter and area, which is a very fun subject. But first, we're going to drill our multiplication times 2, because I've noticed that a lot of you are a little rusty on your multiplication facts. So we're just going to use a fun little drill every day until we get a little bit better at those. I don't know if you've ever seen these, but these are called wrap-ups, and they're a lot of fun. So we're doing the times 2 wrap-up. So we start over here with number 6. And then 6 times 2 is 12, so we bring it over to the 12. And 5 times 2 is 10, so we bring it over here to the 10. And then we go to the next one. 9 times 2 is 18, so we find the 18. And 10 times 2 is 20, and 20 is way down here. And then 2 is the next one there. 2 times 2 is 4. 4 times 2 is 8. 1 times 2 is 2. Now I gotta find the 2. Oh, there's the 2. 8 times 2 is 16. 12 times 2 is 24, right there. 3 times 2 is 6. 7 times 2 is 14. 11 times 2 is 22, and wrap. Okay, so those are a lot of fun, and I have these in my office. If you would like to come by and practice them some, they're a lot of fun. But those are called wrap-ups. Now, to see if you've got them right, you turn them over on the back, and you see if your string crossed. You can see that there's little strips on there. It's hard to see with this, but I can see it when I hold it up close, and it's correct. So basically, you have little strips on the back. I'll show you them. When I unwrap it, can you see how there's little strips on the back there? And they tell you if yours line up on the little strips that are there, then you got it right. I love this lesson because I get to play with blocks. Well, actually tiles. So we're going to play with tiles in a minute. But first of all, let's discuss perimeter and area for a minute. So perimeter is the distance around a figure, and the area is the surface that covers the bottom of the figure. Now we're going to use a room to clarify this. So if we had a room, pretend this is a room, okay, the bottom floor of a room with a nice checkered carpet, red and yellow checkered carpet. Now around the edge of the room, don't we usually have some baseboard along the edges? Okay, so we have baseboard along the edges, and somewhere in there there's a door, but we're just going to forget the door for right now. I just dropped my book. But if I took my marker and I went all the way around this nice square figure, went all the way around this nice square figure, that line all the way around would represent the perimeter of the room. So when I take off my tiles, you can see the perimeter is the outside distance around this rectangular room. Okay, so if each one of these tiles is a yard, then I would have 1, 2, 3, 4, 5 yards this way. Okay, and then of course this is also 5 yards because it's rectangular. And then this one over here would be 1, 2, 3, 4 yards. And 1, 2, 3, 4 yards. Okay, so on this example, if I'm trying to find the perimeter, it would be the distance around, all the way around, which would include 2 5s, which is 10, and 2 4s, which is 8, and 10 and 8 is 18. So 18 yards would be the perimeter, okay? But if I wanted to talk about area, I would say, okay, each one of these is a yard by a yard. So this little square represents a square yard. Okay, that's what we call a square yard. It's a yard by a yard. Okay, so carpet is often sold in square yards. So I would say, how many square yards do I need to cover this room? Okay, so you can pretend this is a model of the room, and I'm trying to figure out how much carpet I need. So first of all, I could count square yards. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 square yards. Oops, that marker's dead. Get another one. 20 square yards. Okay, so square yards is a measure of area, and it means a yard by a yard area. Okay, so now this is going to give me all that I need to do it. But is there a faster way than counting 20 square yards? Can we multiply 5 times 4 to get the 20? Because each one of these rows has 5 on it, but there are 4 rows, so shouldn't 5 times 4 do the trick? And it does. Okay, so let's go back to what we were talking about before. The baseboard around, which I marked with my marker because I didn't have any baseboard that size, the baseboard trim around the room. Did your mother ever have you dust the baseboards? My mother always had me dust the baseboards. I didn't like it. That gives you the perimeter, or the distance around the room. The floor tiles, which in my little model are yellow and red, they determine the area. How many floor tiles could you spread over the whole room? So in our example number 1 in the book, it says we have a room that is 5 yards long by 4 yards wide. And the questions were, how many feet of baseboard? We found out how many yards of baseboard was 18 yards of baseboard. Now we have to figure out how many feet of baseboard. And then the second question was, how many square yards of carpet? Well, we already figured out the square yards of carpet. The square yards of carpet is 20 square yards. So for example 1, we only need to do a little bit more work, and that is change 18 yards to feet. So let's do that. Okay, so now we're going to go back to our conversion problems, and we're going to change 18 yards to feet. And we have to think about, what conversion factor are we going to use? We know that 3 feet equals 1 yard, or are we going to write it 1 yard equals 3 feet? Remember, we're trying to go to feet, so we want feet on the top. So 1 yard, 3 feet. So we're going to multiply 18 times 3. So we're going to get 54 feet is the distance around that room, or the perimeter. The formulas that we need: perimeter, the distance around, is twice the length plus twice the width in a rectangle. Now let's look back at my first example. Twice the length was 10. Twice the width was 8. When I added 10 plus 8, I got the 18 yards. Then I converted the yards to feet. Okay, then we have our area formula. Length times width is the area. And didn't we find that one was true? We counted all the squares and found 20 square yards. But then we realized we could multiply 5 times 4 and get 20 square yards a lot easier. Now, the reason it's square yards is this is 5 yards and this is 4 yards, and yards times yards gives you square yards. 2 to explore what happens when we double each side of a rectangle. What happens to the perimeter and what happens to the area? Now, you can see that I ran out of little squares because this is just a little demo set, but we can still figure it out, okay? Because we remember the first problem was 5 times 4, 5 yards across and 4 yards down. This time we have 10 yards across and 8 yards down. So this is twice as big a room. We doubled each side. Okay, so let's talk about perimeter. We had 10 yards plus 10 yards. Twice 10 is 20 yards. Okay, I keep on letting that dry out on me there. 20 yards. Plus, this side is 8 and this side is 8, and 8 plus 8 is 16 yards. So twice the length plus twice the width is 36 yards. Okay, now if you remember back from the very first problem we did, we had 18 yards and 20 square yards. So 18 yards has been doubled to 36 yards. So if we double the length of each side, we double the perimeter. But let's see what happens to the area. Okay, remember the area is length times width. So what is 10 times 8? 10 times 8 is 80 square yards. Okay, now look back over here at our last example. Over here, 20 square yards, and then we doubled the sides, and now we have 80 square yards. So what do we conclude? When we double the sides, our perimeter also doubles. But when we double the sides, the area becomes times 4, because that increases by 2, a factor of 2, and that increases by a factor of 2, and 2 times 2 is 4, so the total area increases by a factor of 4, or times 4. Now, what if we were to multiply each side by 3? Then couldn't we expect the perimeter to also multiply by 3? That's what this is showing, isn't it? But what about the area? If we multiply one side by 3 and the other side by 3, 3 times 3 is 9. So the total area would be times 9 of the original area. Okay, so now we get to really start having some fun. All right, so we are going to find the perimeter and the area of this room. So maybe this is a room that has a closet over here, and this is a doorway, but we're trying to find the area of a room that's not just a rectangle. It's almost like 2 rectangles put together. So when we're finding the perimeter, we first have to have every side represented with a number. Well, I have 5 and 10 and 12 and 6, but then I have 2 that are variables, which means I don't know them yet. But let's look at them closely. If I know that this is 5, then isn't this distance 5? If that is 5 and this distance is 12, then what is this distance going to have to be? Okay, doesn't this distance here plus 5 have to equal 12? Now, one thing they tell you in this is that everything that looks like it's a right angle is a right angle. And all of these are right angles, even though Mrs. A doesn't draw real well. They're all right angles. So just pretend that we have a right angle here, right angle here, right angle here. everywhere we have a right angle. And these are perfectly straight lines, even though they don't look like it on my board. So what we're going to do is say 12 minus 5 gives us 7. So this little side here must be 7. And then we have this long side is 10, but this short side over here is 6. So we're trying to find out what V equals. Okay, so since everything is right angles, shouldn't 10 be 6, because this distance right here must also be 6. 6 plus V is 10, so isn't V going to be 4? See how easy it is to find those? So now we can find the perimeter. We're going to say 6 plus 7 plus 4 plus 5 plus 10 plus 12. Okay, so we have to add all of those together. Let's see if we can do it easier by making groups of 10. Here is a group of 10, and here is a group of 10. Okay, so 10 and 10 is 20, plus 12 and another 12 is 24. So 20 plus 24 is 44. Now, I didn't write it down, but all of these were centimeters. Centimeters everywhere. So that's going to be 44 centimeters, and that is the perimeter. So we'll just put a P there for perimeter. Now, how are we going to find the area? Area is length times width. So to find the area of this figure, I'm going to show you, we're going to do it 2 ways, just for fun. Okay, so first we're going to make 2 small rectangles. We'll make this little rectangle here and this little bit larger rectangle here. Okay, this is 4 times 5. 5 times 4 is 20 square centimeters. Okay, and then 12 times 6 is 72 square centimeters. And 20 plus 72 is 92 square centimeters. Now, let's change it up a little bit. Let's take that line away. And let's split up our area a little differently. Okay, so now this rectangle is 5 times 10, which is 50. We should come up with the same area, shouldn't we? Even though we're doing it a different way. This little rectangle is 7 times 6 is 42. What is 50 plus 42? 92 square feet again, isn't it? Okay, so you're going to be doing a lot of these problems in your homework. Let's do some practice. Here is our first practice problem. So we have 12 feet, 8 feet, simple rectangle. This should be easy, especially since this is feet, this is feet. We're asked how many square feet and how many feet of baseboard. So there are no conversions in this problem. Okay, so how many feet of baseboard? So we know that is perimeter. Perimeter is the distance all around. We know if that is 12 feet, then that is 12 feet. If that is 8 feet, then that is 8 feet. And we can see why the formula is twice the length plus twice the width. So twice the length is 24 plus twice the width is 16. Okay, so your formula for perimeter is twice length plus twice width. Okay, so now we're going to add those together and get 10 plus 4 is 10 and 40. Okay, so the distance around is 40 feet. 40 feet. Because it's a distance, it's not square feet. Area is square feet. So now we're going to do how many 1 foot square tiles will cover the floor. So you remember, if I were to do this with blocks, I would have 8. Oops, I need to make those a little closer together. Okay, I would have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so area is length times width, isn't it? Because 12 times 8 is 96. We have 96 square feet. Square feet. Remember, it's square feet because each one of these little square feet is a foot by a foot. And feet times feet is square feet, or feet squared. Okay, so this is practice problem B, and we're looking at a 3 centimeter by 4 centimeter rectangle, and we're going to find the perimeter and the area. So when you're doing this on your homework, perimeter equals twice length plus twice width. That's your formula. Now you're going to take the 3, and we'll call that the width. And we're going to take the 4, and we'll call that the length. And we're going to have twice 4 is 8, plus twice 3 is 6, and 8 plus 6 is 14 centimeters. Okay, so that's the perimeter. Now area is length times width is area. So length is 4 times width is 3. 4 times 3 is 12. But since it's area, it's square centimeters. Square centimeters. 12 square centimeters, and 14 centimeters is the perimeter. Okay, so this is practice problem C, and we have a 9 centimeter by a 12 centimeter rectangle. So I've already put your perimeter formula on. This would be part of your work. Twice length plus twice width is going to give you the perimeter in centimeters, because that's centimeters and that's centimeters. Our area is length times width, and it's going to be in square centimeters, because centimeters times centimeters is square centimeters. So it would be smart on your homework to go ahead and set this up and then go look for your numbers. Okay, so twice the length will make 12 the length. We'll erase length and we'll put in 12. And twice the width is going to be twice 9, 24 plus 18. 24 plus 18. 4 plus 8 is 12. Carry the 1. 2 plus 1 plus 1 more is 4. So 42 centimeters is the perimeter. Length is 12 times width is 9, and we know that 9 times 12 is 108 if we know our times tables, and 108 is in square centimeters. That was C in your practice problems. Okay, watch carefully. This is example D, and it brings up something that a lot of you are going to have trouble on, so watch very carefully. Notice that B was 3 times 4, and C was 9 times 12. So in D, they bring up that 9 is 3 times 3, and 12 is 3 times 4. So just like in example 2, we doubled all the sides. Here, between B and C, we have tripled or multiplied by 3. Now remember what we learned in example 2. If we multiplied by 2, the perimeter was twice the original perimeter. If we squared to get the area, then it was 4 times, because 2 times 2 is 4. So let's think about this. If we multiply by 3 on each side, shouldn't the perimeter of the new triangle be 3 times the perimeter of the old triangle? Okay, and the area is going to be, since it's times 3 on this side and times 3 on this side, 3 times 3 is 9. So the area should be 9 times the area of the original triangle. Let's check it. Remember, the original triangle here was 14 centimeters in perimeter and 12 square centimeters. 4 times 3 is 12. But over here, okay, it was 42 centimeters. Guess what? 42 is 3 times 14. But 108 is 9 times 12. Okay, so perimeter is going to do exactly what you do to the sides. So if you multiply the sides by 2, the perimeter is going to double. If you multiply the sides by 3, the perimeter is going to multiply by 3. But the area is going to square whatever scale factor you use. Okay, so we scaled up by a factor of 3. Therefore, 3 times 3 is 9. The area will be 9 times, and it is. Sample problem E, practice problem E. Placing 12 tiles side by side, Pete can make a 12 by 1 rectangle. Name 2 other rectangles Pete can make with the 12 tiles. Okay, so here are our 12 tiles. And the 12 tiles put like this make 12 times just 1, or a 12 by 1 rectangle. Anytime we're writing a rectangle, we can put times for by. 12 by 1 or 12 times 1, that means by usually. Okay, oops. What other rectangles could we make? So we're going to think of what other factors of 12. So could we say 2 times 6 is 12? Yes. Could we say 3 times 4 is 12? Okay, so let's try it. If we did 2 times 6, 1, 2, 3, 4, 5, 6, and we slid these down here, could we make a 2 by 6? Okay, so we can make a 2 by 6. What about a 3 times 4? 1, 2, 3, 4. What if we take these off and bring them down here? Could we make a 3 by 4 rectangle? And we could. So your answer is 2 by 6 and 3 by 4. And it doesn't matter. It could be 6 times 2. It could be 4 times 3. It doesn't have to be in order because multiplication is commutative. Okay, for our last practice problem, we're to find the perimeter and the area of this figure. Again, pretending that all the angles are right angles and all the lines are straight lines. Okay, so we have some missing things. We don't know what this one is. We don't know what this one is, but we have enough information to find them out, don't we? So if this side is 14, if we were going to extend this one down, wouldn't this whole side need to be 14 also? Okay, so you can often just make a little pseudo triangle in there. You're not talking about that triangle, but it might help you visualize. Okay, so here we have 11 feet, and we have 14 over here, so 14 take away 11 should be this distance here, which we'll just write right here, okay, because this is a little rectangle. So 14 take away 11 is 3, so this is 3 feet. And then across here, we have to figure this one out. 13 feet, 3 feet. This right here is the same as this one right here, so 3 feet plus what gives me 13 feet, and doesn't this one have to be 10 feet? Okay, so I'm going to show you something fun here. First of all, let's talk about perimeter, the distance around. Now that we've figured out our missing sides, it's easy, isn't it? 13 plus 14, so let's write them down. 13, 14, 3, 3, 10, 11. Okay, now we have to add them all up. 3 plus 4 is 7, plus 3 is 10, plus 3 is 13, plus 1 is 14. 1, 2, 3, 4, 5, 54 feet is my perimeter. Now we're going to figure out the area 2 ways, okay? So I've already got this little line here. I'm going to keep that line there, and I'm going to say 13 times 11 would be this one right here. 13 times 11. Well, 13 times 11 is 13 and 13 slid over, so that's 143. Okay, now let's come over here and do this one, which is 3 times 3, which is 9. And 143 plus 9 is 152. 152 square feet. Now, let's do it another way. Let's take this off. Let's come up here. Okay, so this one was 143 plus 9 equals 152. Now let's erase all of that. Remember, this was 10. Okay, this is 11 here because that's 11. And we're going to take this one off and divide it this way. So this is 11 times 10, because remember, this is only, part of this is going this way. So 11 times 10 is 110. Okay, and then this long one here is going to be 14 times 3. And 14 times 3 is 42. And 110 plus 42, guess what it is? 152. Now, for those of you that are good abstract thinkers, I'm going to show you one more, even quicker way. When we have a simple figure like this with just one little hook in it, you can, so basically it's like a little L-shaped figure. You can do this very easily by saying, okay, let's take the whole thing like it's a square and subtract this little imaginary triangle here, because it's not part of the figure, is it? So if we took the whole thing as a square, we'd have 14 times 13, but then we would subtract 3 times 10, which is 30. Okay, so let's do 14 times 13 is 12. 42 and a 14 slid over, so that's 182. Take away 30 is 152, and we get the same answer. Isn't that cool? Okay, well, we're done with our lesson, but I'm going to do a few of your actual lesson problems for you, so that if you need help, you've got it on the video. So if you understand everything perfectly, stop the video now and go do your homework. Okay, if you need a few more examples, that's what I'm doing right now. I'm giving you a couple more problems to help you along with this new material. So let's listen to number 1. Joel will fence a rectangular yard measuring 20 yards by 15 yards. How many yards of fencing will he need? What will be the area of the fenced yard? Now, if you're talking about the fencing, You're talking about the perimeter, aren't you? Okay, so here's our information here. So Joel wants to make a 20-yard by 15-yard yard. Okay, so the yard, maybe he's going to fence it in for his animals. I don't know. But he needs yards of fencing. How many yards of fencing? And what is the area of this yard? Now, I didn't draw the yard because it's just going to be 20 yards and 15 yards. We know the formulas, though. If we're trying to find the fencing, we're trying to find the perimeter. So perimeter is twice length plus twice width, which is twice 20. Twice 20 plus twice 15. 20 times 20 is 40. 2 times 15 is 30. 40 plus 30 is 70 yards of fencing. So we're going to put 70 yards of fencing. Now, what is the area of the yard? Now, we know that the area is always in square yards. So we'll put square yards so we don't forget it. And 20 times, so area is length times width. 20 times 15, 2 times 15 is 30, and then tack on another 0 is 300. 300 square yards is the area inside his fenced yard. And that was number 1. Hope you got it down on your work. Okay, example number 2. Now, problem number 2 in your homework says, suppose Joel wanted to build a yard that was 4 times on each side the original yard. Remember, the original yard in problem 1 was 20 by 15. So if he's going to multiply each side by 4, he's going to get 80 by 60, because 4 times 20 is 80 and 4 times 15 is 60. Now remember, if we multiply the sides by 4, we also multiply the perimeter by 4. Since 4 times the original size, the second perimeter of the bigger figure is 4 times the original perimeter, that figure, okay? The perimeter of that one was 70, remember, because twice 20 is 40, and twice 15 is 30, and 40 plus 30 is 70. So the original perimeter of the smaller rectangle was 70. So the new one should be 4 times 70, or 280 yards. Now let's see. Remember, we've got a new rectangle. Let's check it. Twice the length is 160, plus twice the width is 120. And when we add those together, don't we get 280? Okay, I want you to see that it works. Now, go back to example 2. This is what we're doing. Example 2 is what we're looking at. If we multiply the original figure by 4, and we have these new dimensions, that means the area of the original figure will now be multiplied by 4 squared, or 4 times 4, or 16. So we're going to multiply the original, which was 300. When we multiplied those together, we got 300 times 16 is 4,800 square yards. Okay, now let's check it. 80 times 60, 8 times 6 is 48, tack on 2 zeros. Don't we get it? We do. Okay, so I'm going to hold that one up because that's got a lot of work. But what I'm trying to get you to see is that when we multiply the sides by a constant scale factor, the perimeter of the old figure will be multiplied by the same scale factor. If we are looking for the area, we're going to multiply the original area by the scale factor squared. Okay, I already did problem number 3 for you in problem number 2, but let's look at it. Since we multiplied problem number 1's problem by 4 to get problem number 2's problem, then the perimeter is also times 4. So the second larger perimeter is 4 times the smaller perimeter. The area, however, is this scale factor squared. So it's going to be 16. 4 times 4 is 16. So 16 times the area that we first started out with in problem number 1 is going to be our area in number 2. And that's the answer to number 3. Not confusing at all, is it? And the last problem that we need to do today is the last of the new material, which is number 4. And it says, placing 30 tiles side by side, Patricia can make a 30 by 1 rectangle. Name 3 other rectangles that Patricia could make with 30 tiles. So what are we looking for? Factors of 30. So here we've got 30 tiles side by side, so she could make a 30 times 1. Or suppose she made it 2 tiles high, couldn't she make a 15 times 2 gives you 30? Or if she made it 3 tiles high, couldn't she make a 10 by 3 rectangle? Okay, and we still have one more because that was the original one. And what if we made 30 is not divisible by 4, but what if we used 5? Then wouldn't the other number be 6? A 5 times 6 or 5 by 6 rectangle? Now, Miss A has done all of your new problems in your homework for you. All of the other problems are old problems. Have fun!